So for the first question on the video bonus assignment, I've chosen to find the area between y equals x to the 5 and y equals x cubed. By inspection, we should come to the conclusion that this requires us to do an integral of the area, which is integral from a to b, top minus bottom dx. Now, to find out which one is top and which one is bottom between those two, you're going to have to set up a point of intersection. So, equal x to the 5 equals x to the 3 to find the point of intersections. Bring it over to one side. 0, factor out an x cubed. You're left with x squared minus 1 inside equals 0. Setting this to 0, you'll get x equals 0 and x equals plus or minus 1. Now, as you can see, we have from a to b, which are two parameters, and we have three values when we find a point of intersection. This requires us to do two separate integrals. So I'll rewrite this as integral from -1 to 0, top minus bottom dx, plus the integral from 0 to 1, top minus bottom dx. Now, to find out which one is top and which one is bottom, on each separate integral, you're going to have to set up the interval from -1 to 0 of x to the 5 and x to the 3. So now we have to sub in a value between -1 and 0 into each of those functions to find which one is a greater number in that interval. So I'll choose to sub in x equals -1/2 into both functions to find out which one is greater in that interval. And then this will equal -1 over 32, and this will equal -1 over 8. So we should find out that this one is actually a greater value in the negative interval. And then for the second integral between 0 and 1, let me rewrite that, 0 and 1 of x to the 5 and x to the 3, we must sub in a different value between 0 and 1, which is positive. So I'll just choose 1/2 again. And then 1 over 2 cubed. This will give us 1 over 32. And then this will give us 1 over 8. So in the other interval, we find that x cubed is actually a greater value in that interval. So let's rewrite our integrals again. -1 to 0 of x to the 5 minus x to the 3 dx, plus 0 to 1 x to the 3 minus x to the 5 dx. Now we see a subtraction sign in between, so this means we can do each integral separately. So this will come out to x to the 6 over 6 minus x to the 4 over 4 plus this integral, which is x to the 4 over 4 minus x to the 6 over 6. And then this is evaluated from -1 to 0. And then this integral is evaluated from 0 to 1. Now, when we sub in these values, we go from the top interval, from the greater interval first, minus the second interval, which is the smaller 1 second. But subbing in 0 will give us 0 into the first equation. And then we have to subtract the -1 portion of it. So we have to put a negative sign at the front and then sub in -1 into each x in the integral. So -1 to the 6 over 6 minus the minus of 1 to the 4 over 4 plus, now doing it for this integral will not make a difference. We won't have to put a subtraction sign later on because we'll be subtracting 0, which does not make a difference. Carrying on, sorry, my capacity for the time videotaping got reached. Carrying on, subbing in 1 into these x values will give us 1 over 4 minus 1 over 6. Now, this will give us the negative of 1 over 6 minus the positive of 1 over 4 plus 1 over 4 minus 1 over 6. Once we expand out this negative, we'll get negative 1 over 6 plus 1 over 4 plus 1 over 4 minus 1 over 6. Now, finding a common denominator, we'll set it as 12, so negative 2 over 12 plus 3 over 12 plus 3 over 12 minus 2 over 12. And then collecting common terms, we'll find out that this equals negative 4 over 12 plus 6 over 12, which will equal 2 over 12, which will simplify to 1/6. And there you have it. The area between x to the 5 and x to the 3 will eventually give you a value of 1/6. Alright, for the second question for the bonus video assignment, I've chosen to do the question where it asks for the integral of pi to the x plus 1 over the root of 1 minus x squared plus the secant of 3x dx. Now, by inspection, we can find out, because they're separated by addition sign, we can break this into 3 separate integrals, which may be easier to the eye. So I'll just do that right now. Of pi to the x dx plus the integral of 1 over 1 minus x squared. Take that root dx plus the integral of secant 3x dx. Now, by inspection, based on lecture notes, etc., we should find out or know at the back of our minds that the integral of a number, because pi is just a number, to the x is actually that number to the x over the ln of that number. So this integral will actually equal pi to the x, because pi is just a number, to the x over the ln of pi. And then if we remember our inverse trig functions, that is the derivative of arcsine. So the integral of this function will give us arcsine. So we'll find out that this gives us arcsine x, or sine to the negative 1x, same thing, plus, so the secant function is similar to the sine and cos function, taking the derivative of them. So to the side, I'll just write in, let's see, the integral of cos 2x. As I said, it's similar, so the integral of cos 2x is sine 2x over 2. Now we know that the derivative of tan gives us secant squared, but then this will mean that tan actually had an x value of 3x, but we must do the same thing as we did for cos. We must divide it by that same coefficient on x. So this integral will actually give us tan of 3x, and as I said, we must divide by that coefficient on x, divide by 3. So there it is, the integral of pi to the x, which is just a number to the x, is ln, or which is pi to the x over ln x right here. And then we identified this as the derivative of arcsine. So the integral of this function will be arcsine, as I stated right here. And then we also identified that tan x gives us secant x squared, but then the x of tan is actually 3x, so we must divide by the coefficient on x, which is 3, as I stated right here. So that is the integral of pi to the x plus 1 over root of 1 minus x squared plus the secant of 3x dx.